Record. All right, now I'm going to screen share. All right. Basic trig equations. Equations means we're solving for theta. When you see equations, it means equals what? Some unknown somewhere, somehow, that we have to solve for. And our solutions are our zeros, generally speaking. So it's talking about our solving. It's talking about how we do it, which is normal. Like this is just the different ways. It kind of lists some of them in the textbook. So just throwing this out there again. So it's a kind of a comfort level thing. I've removed from the assignment questions where you would require the quadratic formula. We're not going to do that. But you may need to use identities to make some substitutions before you solve. It says not with technology. Excuse me. It says not with technology, but I put the stars there to say use technology. Sorry, just remembered my vitamins. Use technology to play, to see how it goes, to confirm your suspicions and otherwise, but it's nothing you can lean on for the test. So it's talking about specific solutions within a specified domain. Pay close attention to the domain. If it's like 0 less than theta less than 2 pi, and not saying less than or equal, then 0 and 2 pi are not viable solutions. So pay attention to your parameters. General solutions means all possible solutions. So it's using n for natural numbers, because some places the textbook it uses natural numbers. Some places it uses integers, which is z. I prefer integers. It uses natural numbers when it uses the plus minus symbol. I'd prefer integers. That takes care of it. But as long as you're covering your base, I'm not going to give you grief. Jamie, can you tell me when you're done writing, please?
Yeah, I will.
Oh, you're done now? Okay, thanks.
Okay, I'm done.
Anybody else still writing?
No.
Totally just waiting for Gavin's voice. Ignore that for a second. I didn't animate that apparently. Jamer, tell me when you're done, please, kiddo.
Okay, I'm done.
Anybody else done writing?
Nope.
Okay, we're gonna go through these examples. 1 and 7, the assignment, they're optional. It's graphing. Please don't see that as, oh, don't have to do them, done. Think about it, consider it, see just how these things kind of line up, what it's like to solve with graphing, which we really don't do. They do it in applied and in university. It's relatively easy to figure out, but so do it. Anyway, blah, 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 2 days. So I'm thinking, because today it's going to take me, I think, a fair amount of time to go through the examples and everything. I'm not going to do 6.5 from the textbook. That's all graphing. I feel like we're getting days taken away left, right, and center. So I'm not concerned, but I just want to be aware of the time we have left. So anyways, we're not going to do 6.5. I'm going to assign this today. There won't be anything new tomorrow. So tomorrow will kind of be like practice. And then I'm thinking Thursday, study day. So really, in a sense, tomorrow and Thursday, study days, practice days, whatever. Monday, test. Any issues anybody see with that to start?
So the people at home on Monday would do it at home?
Well, because we have, assuming we have regular school Monday and Tuesday, we can do it in person. So people there Monday do it Monday, people there Tuesday do it Tuesday. Or what do you guys think? I don't think there were any big problems with me sending them home. Is everybody okay with doing it at home?
Yeah.
Anybody have issues with that? Because then maybe we'll just do that again. I think it worked okay. Okay, so test Monday. We'll touch base tomorrow. Still got tomorrow and Thursday. We'll touch base and make sure everybody's copacetic. But yeah, okay, we'll do Monday for everybody, in person or otherwise. This is in the bottom of 210. If you want to copy this down, you can get it from page 210. It's a good idea, good little reminder. I wasn't sure if it should be in the notes or not. So you read it and you decide what you want to do with it. Bottom of 210, and I'm sure you've already had time to read it. So let's get to examples. Starting on page where? What did I say? 210. Okay. Is this going to stay with me? Oh, screen sharing's paused. That's okay. Don't need to screen share for a second. Page 210. I'm going to go through most of the examples here. I'm eating this vitamin C thing, and it is so sour. I don't remember them being this sour. Holy moly. Puckering up my face. Okay, so very first example. Man, I woke up to a negative test, so I'm not COVID positive. My cough is just worse. Okay, so the first example says solve 2 sine of theta minus 1 equals 0. So it says A over 0 to 2 pi, and B is over real numbers. Okay, let me change to my camera view, make sure I'm even on camera. I'm gonna have to go back and forth a bit. Okay, can you guys see that okay? It's not the best, it's not getting most of my light from natural light, it's pretty gloomy out. 2 sine of theta, excuse me, minus 1. We're solving for theta, okay? So if this was like 2x minus 1, you would know what to do. So it's the same idea. I'm gonna add 1 to both sides. 2 sine of theta equals 1. Divide both sides by 2. Excuse me. Sine of theta equals 1/2. So now, what does theta have to be such that the sine of it is 1/2? This is why you'll be given a unit circle, and you can fill it out as you need it. But that's just ugly. In your unit circle, the sine being 1/2, excuse me, are going to be like this 30-degree angle and this 150-degree angle. we're doing this over pi, like in radians. So this is pi over 6 and 5 pi over 6. Those are the answers when it's between 0 and 2 pi. Answers are pi over 6 and 5 pi over 6. So for the answer for A, excuse me, pi over 6, 5 pi over 6. Those are the answers for B. It's the same thing, but we add 2 pi times k. Some places in the textbook it uses n. I don't like it using lowercase n because capital N is natural numbers. Could be confusing. But in this case, you're saying k is an element of integers, which means it's positive or negative 1, 2, 3, 4, blah, blah, blah. So it's just talking about like these answers and all possible coterminal angles, doesn't matter which way you go around. Does that make sense? Anybody have questions? Hearing none. Please don't. Oh, go ahead.
No question.
You say what question?
No questions.
Oh, thank you. So I got that from the top of 210. Moving on to 211. They're starting to number the examples here. So this is where we're gonna go. So number 1 says solve. So this is sine squared theta minus sine of theta equals 0. Excuse me. Goodness, I'm driving myself crazy with my throat. Wants to do this kind of between 0 and 2 pi again, same, and over the real numbers. So in this case, think of this as x squared minus x. So I'm gonna factor an x out. So sine of theta times sine of theta minus 1. And so we find our zeros. So for sine of theta to equal 0, that was a better circle. Sine equals 0 at 0, at pi, and 2 pi. But remember, the parameters is given us, oops, there's no comma, 0, theta, come on, and 2 pi. It's not equal to. So 0 and 2 pi are not viable answers over this domain, just pi. So that's one of them. So like part I, so it's pi. Now sine of theta minus 1, what makes that 0? If you're kind of confused, remember when it's x minus 1, then x has to be 1. So in this case, what does sine of theta, if we had this as like sine of theta minus 1 equals 0, sine of theta equals 1, what value for theta equals 1? Well, that would be pi over 2. Down here, it's negative 1. But up here, it's pi over 2. So our two answers are pi and pi over 2. Those are the ones that are within this domain. Over the reals, it's the exact same thing, but now we're adding the period. If this was tan, and I don't know if you're doing any tan, then the period is just pi. But sine and cos, the period is 2 pi. It takes 2 pi to go all the way around again. So little tiny trick here, notice we've got pi comma pi over 2, but also we know that these were answers. Remember, we had to exclude them, or sorry, not this one, but these were answers. We had to exclude them because of the parameters here, so we can add it back now. And 2 pi, no comma, plus 2 pi k, where k is an element of integers. Oh, you know what? Sorry, I just got, because I was sick, all these appointments changed and stuff like that, and I just got a weird text from my daughter. I'll be right back. Evan. Sorry, guys, if that wasn't important, I wouldn't have done that. Any questions about what we got there?
Nope.
Cool. All right, let me just find. Next question. Number 2, 4 cos squared theta minus 1 equals 0. Okay, so same parameters. I got the same question, the same parameters. A few different ways to do this, because this, you can see it's a difference of squares. 4 and cos squared theta minus 1. Man, I went downstairs out of breath. So you could do the difference of squares way, but it's a little bit easier if you just go the isolation way. I'm just isolating it. And now I take the square root of both sides. The thing is, when you're doing it with solving, it's plus or minus. So I take the root of both sides. The root of 1 over 4 is 1 over 2. The root of 1 is 1. The root of 4 is 2. But the root of anything is plus or minus. This could be negative a half, because negative a half squared would be positive 1 over 4. So the places where, excuse me, cos of theta is a half, it's our kind of 60s. Those aren't drawn super great. This is pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Those are where cos of theta equals positive or negative 1/2. Those all fit between 0 and 2 pi. So our answer for I is all those. So it's pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And then for part, the second part, like the general solution, it's again just all this plus 2 pi k, where k is an element of the integers. If you're already tired of hearing my voice, don't worry, you're not alone. Questions about that?
Nope.
So this is all making good sense? You guys are just right on with it? I assumed there'd be more questions. Remember that plus or minus when you're rooting, when you're solving, especially. Okay, let me just look up the next question. Okay, here's where we got to get some factoring. A new piece of paper, more junk pile. So this is example 3. 2 cos squared theta minus 7 cos of theta minus 4. So like I mentioned before, you can treat these like x's if it's kind of easier in your brain to say, okay, excuse me, 2x squared minus 7x minus 4 equals 0. You want to look at it like that to factor it, then do. And then just change it back. That's 2x and x. 2 minus 4 would be -8 plus 1 -7. So I did it with, I wrote it, I took the black pen because I meant to write it with cos and then I didn't. Whatever. 2 cos of theta plus 1 times cos of theta minus 4. Oh, this is a good example. I'll show you why. So here, 2 cos of theta plus 1, you want that to equal 0. That's going to be cos of theta equals -1/2, right? If we treat this in brackets equal to 0, isolate the cos of theta. This one here, cos of theta equals 4. This one is no solution. There's no solution for this because remember, cos of theta is opposite over hypotenuse, or more recently, x over r. We cannot have a side bigger than the hypotenuse, let alone like 4 times whatever the hypotenuse is. Okay, x has to be smaller than or equal to 1.
I think you mean adjacent, but like it's the same thing.
Oh, sorry. Yeah. Sorry. Thank you. Good. People are paying attention. I did that just to see if you're paying attention. Is that the dumbest, oldest teacher joke? Thank you for picking up on that. Yeah, it is adjacent. It's the x value for our reference angles. So there is no solution for this. Everybody understands why there's no solution? Tan of theta, the numbers can be bigger. Opposite over adjacent can be 4 over 3. It can be bigger than 1, not with cosine. See this instantly? No solution. Negative a half for cos of theta. The rest of this is academic now. Negative a half, so it'll be like this, or like this. So these are 30-degree angles. So this is 150 or 5 pi over 6 and 7 pi over 6. And then you just do the rest. That's good for between 0 and 2 pi. And then you can, for over reals, it's just that plus 2 pi k, where k is an element of integers. Who's talking?
Aren't those cos of negative root 3 over 2?
Cos is negative.
Like those
Oh
x values.
Yeah. Oh, I'm falling apart. You're right. Cos is a half. Cos is the shorter version. You're right. Yeah. So this is 2 pi over 3. And this is 4 pi over 3, right? Is that right? Am I doing it right now?
Yes.
We're still paying attention.
Good. I'm glad because my brain is trying to check out apparently. I did not sleep well. I think I'll leave the computer on, but I think I'm just going to lay down after this. You feel free to buzz me if you need help. Okay, so we're good with that mess. No solution, and then might as well write it out. 2 pi over 3, 4 pi over 3 for B. It's those things, plus 2 pi k, where k is an element of the integers. Does this look like a face? Here's the mouth, here's a weird little chin, this little nose, and these 3s are eyes? Or is this the cold meds?
It looks
like a jack-o'-lantern or something. Yeah, I'm an artist. You're welcome. Everybody got this down? Any questions before I move on? All right. Next, I'm gonna start getting picky. Yeah, okay. I don't know if you guys are looking, if anybody's looking at their book, but question number 212, I'll write it, not 212, page 212. Question number 4. You guys can see my hand right now, right?
Yes.
Okay, so 4 is 3 sine squared theta plus sine of theta minus 1 equals 0. This one's not factorable, which brings in the quadratic formula. We're not going to do anything with the quadratic formula. So like anywhere, when we get into review and practice and things like that, if somewhere the quadratic formula shows up, skip it. We're not doing it at all. Like we're not paying it any attention. So just know that. Those are the non-factorable ones, not necessarily the ones that you can't see how to factor, but the truly non-factorable. Okay, number 5. I'll do this just to show you guys. So number 5 says 3 sine squared theta plus sine of theta. I don't know why I put that in brackets, plus sine of theta minus 1 equals 0. So is this the same one that we just had, except to do it by graphing. I'll show you how to do that. Got to share the screen. Let's learn together. Okay, so y equals 3 sine squared of x plus sine of x minus 1. So the equation we get is 3 sine squared of x plus sine of x minus 1 equals 0. So in other words, when does this equal 0? At all these intercepts. At every single one, those are the solutions. If it's between 0 and 2 pi, then it would be not even this one, because this is higher than 2 pi, right? So for this question, it would be these two answers. And then for to do over the reals, you could list every single one of these forever. I don't mean just what's on the screen. I legit mean forever. Or you could just say these two plus 2 pi k, where k is an element of the integers. Who was trying to say something there?
Isn't 2 pi like 6 point something?
Oh yeah, it's not 4. Goodness, you guys. These are your answers. These are your answers. Why am I like I legit should have just called in sick. I do not want to be causing more trouble. I did in my head, 2 times 3 is less than 4. This is the guy teaching you grade 12 pre-cal right now. Thank you. Did I tell you guys about, I had this linear algebra professor in university. He was terrible. He was hard to understand. He was angry. He would write stuff and they'd say, any questions? Questions, anybody? And he was always super aggressive. Any questions? Questions, you guys? And people were like freaked out. Nobody's saying anything, even though nobody knew what was going on. Questions, you guys, come on. And then he's getting upset because nobody's asking questions. Come on, you guys, ask questions. Say something. So someone says, how did you get? He's like, what do you mean how? It's right on the board. Why are you asking such a stupid question? So I'm glad that you guys are comfortable to point out my stupidity. Sorry about the confusion. If you might get something like, I'll just make it up, like where 0 equals 3 sine squared, 3 sine squared x plus, should I just stop here? Plus, say root 3 over 2. So if you get something like this, and then you graph it, you're like, well, there's no intercepts. The way to graph it is to make one part of it equal to the other. And then the solutions are the intercepts. Oops, that's not, doesn't count. And we're going to get to that anyway, so I won't say anything more about that till we get to it. Any questions or clarifications from my dumbness? Dumbness is a word. Nobody?
So when we're listing all of the integers, are they positive and negative?
It depends on the parameters that, oh, sorry, be a little bit more specific with your question, please.
For like saying listing all of them that are real,
Yeah,
or like,
then yes, that includes negative. Yeah, that's why I was
Okay.
saying, like, here, I'll put it on my paper for a second. That's why I was saying, someplace in the textbook, it'll be like, whatever, root 3 over 2, doesn't matter. Plus 2 pi, and it'll say like plus or minus root 3 over 2 plus 2 pi n, and it leaves it like this, which implies that n is an element of natural numbers. Natural numbers are counting numbers. which is just positive 1, 2. Why is my phone ringing? Positive 1, 2, Dr. Anang. Hang on, I'm gonna mute you guys for a second. You know when you have a fever and you don't really know, like you, I don't know, hallucinate and just think weird things. I'm having trouble keeping up with things.
All the time. That happens all the time.
Yeah, it's like it's a different world. My daughter's supposed to have an appointment today, and also I have in the back of my head, they said if your COVID test is positive, they will call you, answer the phone, you will not recognize the number. My test online said negative, but now I get this Dr. Anang. Well, it had something to do with my daughter. My daughter and my wife are sitting on the computer ready for a virtual appointment. Instead, the guy calls my cell phone. Okay. Did this answer your question, Karina?
Yes.
So like this is a viable way, like this, and this could be K. K is an element of natural numbers. I don't like it. I would just rather root 3 over 2 plus 2 pi K, where K is an element of integers.
Okay.
Cool. All right. What's the next question? Where are we? That's number 5. Number 6. Oh, here we get with the identities. Okay. The doctor just called. He was like, is it okay that I talk to you right now? I don't know what this is about. I don't know why you're calling me. So you're a doctor, yes? Although I got 3 scam calls yesterday for my social insurance number. Apparently something's wrong with it. Okay, so sine squared theta equals 3 cos squared theta. All right, so this one doesn't even want general solutions. It just wants answers. So, oh, where's my screen? There it is. So let me ask you guys before I even start, what do you think we do? What does anything jump out at you after doing all those proofs and stuff?
Divide both sides by cos squared.
Okay, why?
So that you can use the identities to change it, and also because that's what the textbook says.
Okay, so you want to, okay, well, I appreciate you looking at the textbook. So you divide both sides by cos squared, so this becomes tan squared of theta. And this becomes 3, right?
Yeah.
Okay, that's one way of doing it. That's not the way I would have done it. Did anybody see, and we can do it, that's totally fine. I don't want to kibosh what you're saying. Anybody see a different way of doing it?
Can you get the root of both sides?
You can't because of that 3.
Okay.
Well, it would be ugly. It'd be like,
Yeah.
yeah, it'd be like sine of theta equals root 3 cos of theta. Not the worst. I'm just
Divide
asking. Oh, go ahead.
Divide both sides by sine squared, so that becomes cotangent.
Yeah, so you could do it the other way. Sure. Yeah, you got tan, you got cotan. what I would have done, excuse me, is I would have substituted sine squared of theta is 1 minus cos squared of theta. Because then I would have had, I would have had everything in cos. Do you know what I mean? Do you remember how that's the first identity? Where's my identity sheet? Oh, awesome. Oh, there it is. Because the very first one, oh look, it's kind of written there from yesterday, I guess. Sine squared of theta is equal to 1 minus cos squared of theta. So if I would have put that there, I would have had everything in cos. That's where my brain went, is like doing it the tan way. There's nothing wrong with it, but I wanted everything to be cos. So let's do it the tan way. So Matthew says divide everything by cos squared of theta. Because Matthew always gets his way, just kidding. So this is tan squared of theta, which equals 3. So now we take the root of this. So tan of theta equals plus or minus the root of 3. Also, I think, like when I was saying before, when I was talking about cos, it's just easier to deal with. With tan, now we got to think, oh, what the heck is theta? Because tan of theta is, excuse me, sine of theta over cos of theta. So what does it, how does this translate to this? Which would be root 3 over 2, that's the sine part of it, and the cos would be a half. Does that make sense? And so when sine, and so now this tells us what our angles are on the, because I'm not at the level yet where I see this and I go, oh yeah, I know exactly where that is. This now is obvious, right? These are our 60-degree angles. Does that make sense?
Yep.
You guys can see that? How do you guys feel about me doing this the way I was going to do it, just so we can see how that works?
Go for
Yeah,
it.
you should do your way too. But then
Yep.
after tan, do you have to switch it back to like sine over cos to find the answers?
Well,
Is that what you're doing?
unless if you see this, see, I personally need to see this.
Yeah.
If you
Okay.
see this from this, more power to you. That's awesome.
No, I don't.
Yeah, no, I didn't either. And that's what I'm saying, because at the end of the day, you need to figure out what theta is. It's harder to do it this way. So if we go, I'll just rewrite this. Sorry, was everybody done this?
Yep.
Okay. So it was sine squared of theta equals 3 cos squared of theta equals 3 cos squared of theta. My eyeballs are burning. They're burning. Okay, so this is 1 minus cos squared of theta equals 3 cos squared theta. So we're going to add, we want everything basically to go over here. So we're going to add cos squared theta to both sides, and we're going to subtract 1. So it becomes 0 equals 4 cos squared theta minus 1. Remember we had a question like this earlier? And so if we do the simplifying version and bring the 1 back, 1 equals 4 cos squared theta, divide both sides by 4, 1 over 4 equals cos squared theta. Take the root of both sides, plus or minus 1 over 2 equals cos of theta. And remember, I'll come back, but when we were doing it this way, that's what cos was a half, was a plus or minus a half, which is what we have here. And if you're thinking like on the other one, it says, well, and sine is root 3 over 2. If cos is a half, sine has to be root 3 over 2, and vice versa for a unit circle. So this gives us the answers we need. Are you guys with me? Is this okay? What do you need? Besides a nap. Oh, that's me. See, even from far away, I'm picking up vibes that somebody doesn't understand something they don't want to say. I could be wrong. Am I wrong?
That makes sense. It's just finding
There we go.
a
There we
way
go.
to
There we go.
start, you know?
There we go. There we go.
Well,
Yeah.
I just thought you wanted somebody to say something.
I do.
Saying something.
I do. Well, but so you don't have to do it just out of pity. So what you're saying, like that you might not have seen that right from the get go here?
Yeah.
Yeah.
Or
that-
like
that's,
choosing which way it would work out the best, or yeah.
and it's a little bit like when you're doing identities. It's like, I'm gonna try this, but I may have to abandon it and then go a different route. So both of these ways work. In all honesty, this is doing it this way jumps out at me. Sine squared of theta, cos squared of theta. Anytime I see those, I'm thinking I can do something with identities for sure. Like the super duper obvious ones, or if you have like sine of like 2 theta or something, because that's just weird. With this, it honestly, I don't know that it would have occurred to me to make it tan squared. I don't think so. But at the same time, I don't know, whatever. I saw it differently. But that's the cool thing with math is if you follow the rules of math, you will get the right answer. There's different ways to go about it, but as long as you follow the rules, it'll work. Should we move on?
Yes.
All right, what's number 7? Oh yeah, we're not doing stuff like that. As I said, like I said, if you see this, that's an identity. We're not doing questions like this. They don't have these on provincial exams. So proofs, yes, solving, no. So we're not gonna worry about this. Yeah, and those are the last 2 examples. So I think that's it. Where'd my camera go? I think that's it. Any other questions about anything in the world that I can answer for you? Look how ratty this is.
For the assignment, for the graphing questions,
Sorry, say that again?
For the graphing questions in the assignment, would we put into Desmos and just find the zeros, or are we expected to catch it?
No.
Okay.
Yeah, no, don't sketch it. That's that's just kind of a waste of time, to be honest. Anybody
I
else?
have a couple questions from yesterday's assignment.
Oh,
if
right,
we
I never
could
even
them.
got into that. Okay, so before you list them, any other questions about today, you guys? All right, so then let's shift into questions from yesterday. And if you want to hang around, you can. If you don't, you are free to go. Karina, what question do you have?
1F. I
Which page?
think I got it, but page is 208.
Okay, you think you got it? Keep going.
But the answer, I couldn't figure out if I was writing it properly. So, yeah. If you could just do it, and then that would help.
This is the COSA 112.5.
Yes.
COSA of 112.5 degrees. Okay, where's my, there it is. All right, so I want to figure out, so it's a COSA theta. So I'm going to use cos of 2 theta equals 2 cos squared of theta. Is this the one you used? -1.
Yes.
Cool beans. All right, so the cos of 2 theta is the cos of 225 degrees, which equals 2 cos squared theta -1. Cos of 225, excuse me. Uh-oh, somebody wants to come back in. Where is it? Admit. So cos of 225, 180, so it's 25. No, it's 45. So it's 45, so it's -√2/2 equals 2 cos squared theta -1. So now I'm just going to start isolating the cos squared. Excuse me again. 1 plus -√2/2, which is 1 minus 1 minus √2/2. And then that whole thing's going to be divided by 2. And then the whole thing's going to be rooted equals cos of theta. Before I go any further, is this kind of what you were doing?
Yes, but then there was just like lots of stuff at the end and it got messy.
Okay, so I'm gonna keep going, you're saying?
Yes, please.
All right. So this is now, so I'm going to simplify what's in the bracket. So it's going to be 2 minus root 2. I'll just write it. So 2 minus root 2 over 2 all over 2 over 1, which is just the 2. I'm just saying that because it's going to be easier to see.
How did you get the first 2 in the bracket? Is that just 1?
Like this stuff right here?
Yeah.
The 1 is 2 over 2, just so we have the same denominator.
Oh, okay.
And so then when I divide this by this, I'm going to flip this one and multiply, which means these 2's are going to multiply. So it's the root of 2 minus root 2 over 4. And the root of 4 is 2. I can't do anything else with the top ones. So it's, I'm running out of space here. So it's root 2 minus root 2 over 2 equals the cos of 112.5.
Okay, thank you.
Does that make sense?
Yes.
Anybody else? Questions?
I have a question about today's assignment.
Sure. Okay, hang on one sec. This is 1F. I'm just going to say something when I post the recording. Okay, Matthew?
For like questions like 2B where you get like sine of theta equals 5 over 6. How
Hang
do
on
you
one sec. Let me find it. Question 2. Okay, sorry, go ahead.
how do you do 2B? Because like I was able to do 2A because that one's easy and it's like on the unit circle, but 5 over 6 isn't on the unit circle.
Yeah, you're right. Solve 5 over 6. Well, did you look at what the answer says? I'm thinking the answer, if the answer is giving you some kind of a decimal, then it's used quadratic. I didn't think this was a quadratic question.
Yeah, it's like 9 and 2.16. Same with C. Or wait, no, C is different.
Yeah, no, B looked quadratic, so yeah, don't do 2B.
Okay.
Sorry about that. I thought I caught them. Anybody else? Tell the class not to be, please.
Okay.
Anybody else?
Could you do 2C from page 209?
2C, yeah, let me just find it. 209.
Yeah.
I'm gonna find the paper that I've done this on because a few people have asked. Oh, it's right here too. Good thing I didn't throw anything out yesterday. Okay, so okay, just ignore what's on this paper. Oh, I need to see what I'm doing. Okay, so this question, right?
Yes.
Okay, so this one looks most complicated, but also I don't know what cos of 2 theta equals. I know it equals something. So when I check my identity sheet, cos of 2 theta equals lots of possibilities. So because that equals lots of possibilities, I'm not going to mess with that. I'm going to simplify this. I'm going to clean this up. If we just look at like 1 minus tan squared of theta, I'm going to do tan squared of theta over tan squared of theta, or sorry, tan squared of theta is sine squared over cos squared. So I'm going to do cos squared over cos squared. That's going to be my 1 so that I can combine these. I'm going to do the same on the bottom, and then I'm going to be able to deal with these, with this fraction. And so what I do is I multiply the 1s on the top and the bottom by cos squared of theta over cos squared of theta, because I want the same as what's in their denominators. Does that make sense?
Yes. So if sine was on the bottom, then you'd put in a
Sine
sine
over
over
sine.
sine.
You got it.
Okay.
So I do that, and it becomes this. Now notice when I simplify to this, can you guys hear the cat meowing outside the door? Cos squared of theta minus sine squared of theta. This is the difference of squares. So I keep that in mind. I notice that. I keep that in mind. Cos squared of theta plus sine squared of theta. Remember, that's the one identity that I have memorized. That equals 1. So I'm just keeping those things in mind. So this is probably going to be 1. I don't know what I'm going to do with this one yet. But when I flip to multiply, these cos squareds are going to cancel. This equals 1. I've got cos squared theta minus sine squared of theta. Now I'm going to double check my cos of 2 theta, see what that equals. Cos squared of 2 theta, sorry, cos of 2 theta is cos squared of theta minus sine squared of theta, which is what I got here. Does that make sense?
Yes.
So basically what I did with the left side is I just simplified it. And then once I got it to a pretty simple place, and from here, remember, this is difference of squares. I could have factored these if I wanted to, if I needed to for some reason, but I checked to see what the original, what this is supposed to be. And then that told me kind of where to go from there. Does that make sense?
Yes, thank you.
When you're doing unit circle stuff and identity stuff, it's good to have like the sheet, like literally kind of in your other hand, just to kind of constantly refer to. It's a bit of a map that you can't take your eyes off of for too long. Can you dig it?
Yes.
Cool. Anybody else in here? Emma, Gavin, Matthew, do you guys have other questions?
No.
Not really, but I'm just wondering, when do we get to like the right side of the formula sheet?
Right side of the formula sheet. The logs,
Yeah.
I think we're in unit 6. Yeah, the logs are next. So we're doing stuff like this. There's a lot of kind of similarities to identities. It's just kind of knowing the system. Like, remember when you guys saw these, it was probably like, what the crap? What am I supposed to do with all that? Now you have a better idea. Might not be mastered yet, but you have a better idea. That's the way it'll feel with this. And then the last unit is permutations and combinations. This, let's be honest, this is my least favorite unit. Saves the best for last. These are fun. I really like these. These give me grief. Anyways, that answer your question?
Yeah.
Anybody else? All right, friends, I'm gonna end the meeting just for a second. That's the only way I realize I can get the video out of it. And then I'll log on again right away, just in case anybody needs anything. All right. I guess that's all right.